Okay, back at the end of November, DeepSeek released a model that people could access on their site called R1 Light Preview. And this was their first reasoning model, and everyone tried this out, was very amazed by it. I even talked about it in one of the videos. And one of the cool things that they mentioned back then was that they were going to open the weights up for this model. And that's exactly what they've done this week. So the DeepSeek R1 has arrived. And not only is this just one model that it's arrived, there's a whole family of models that they released on Monday this week. So not only have they released the weights for the DeepSeek R1 model, which I'll talk about in a second, they've also released the DeepSeek Zero model, which was a precursor to this. They've also released a number of distilled models, going right down to small models the size of 1.5 billion, which are distilled from this DeepSeek R1 large model. And you can see that if we jump in and look at just the results from the distilled models, a lot of these models are actually doing better than a lot of proprietary models like GPT-4o, Claude 3.5 Sonnet, and even O1 Mini for a variety of different tasks. So later on in the video, I'm going to show you how you can get these distilled models running in a notebook, and also how you could run them locally if you want to use these. These are certainly very interesting models to play with. And the fact that one of them is 1.5 billion parameters, and yet it's able to score higher than Claude 3.5 Sonnet on certain tasks is really amazing. Now, along with the distilled models, the cool thing is obviously that they've released the DeepSeek R1 model. It's MIT licensed, so you can basically use it for the things that you want to use it. They're even allowing you to basically take outputs from this and use it to train other models. So if you've got your own model that you want to use the outputs for this and train, that's okay on this. Now, along with the model, they've also released a paper, which I'm going to go through and talk about some of the techniques that they use to get this model to be so good. And we'll have a look at how you can basically try it out both in the DeepSeek chat interface and also later on in code yourself. All right, so let's briefly look at the benchmarks. And I'm going to point out some things, not just that this model is better than other models, but I'll point out some interesting things about these benchmarks as we go through. As you can see, that the DeepSeek is the model in the blue with the striped lines through it. And you can see that many times it's either on par with the OpenAI 01 model, or it's actually beating the OpenAI 01 model. Certainly out of 3 of these benchmarks, you can see that it's actually beating the full O1 model from OpenAI in here. And each of the time, it's clearly beating, the OpenAI O1 Mini in here. Now, the other models that they've compared it to, I think in some ways are perhaps even more interesting than just the straight up DeepSeek R1 compared to OpenAI O1 in here. If you look at the other 2 models, we've got the DeepSeek R1 32B. So that's the one in this sort of light blue color here. So that model is actually a distilled model from the R1 down to the Quen 32 billion parameter model. The other one that's really interesting is the one that's often the lowest scoring, not always, but you can see often for these ones. And this is the DeepSeek V3 model, which has been very popular over the last few weeks and itself is a very good model. Now, here's the interesting thing, that the DeepSeek R1 is actually using that DeepSeek V3 base model to actually get it going for a lot of the things. So the pre-training of those models, they are the same model. It's just after, how do they apply the reinforcement learning? How do they apply other things in their multi-stage training to get the results out that they do? So DeepSeek V3 is basically a mixture of experts models. It's got a total of 671 parameters, of which at any moment, 37 billion parameters are active. And this is the same in the R1. So you could imagine that the R1, the number of parameters active is very similar to the dense Quen 32 billion model at any moment in time, but it's also got a lot of other parameters in there for different experts that we would expect it to do a lot better, etc. So for me, one of the key takeaways with this is not only is this sort of like a newer model that's bigger or something like that, it's really showing that having a different way of doing post-training is able to get you these fantastic results in here. And in many ways, that fits with what we've seen publicly discussed from OpenAI about the O1 and the O3 models that are out there. So let's jump into the chat and just see how the model performs. Okay, so if you want to test out DeepSeek, you can just come to chat.deepseek.com. They have a demo app there, their own chat app, where you can basically test out using this or the DeepSeek 3 model in here. So I've come in and put a few different questions in here. For me, the really interesting thing is not so much whether it gets it right or wrong. It's really interesting just to look at its kind of thinking process as it goes through this, where it'll start to state something. It will then often clarify to itself about different things. Sometimes it will even backtrack about things just to make sure, where it'll ask it things like this, but I need to confirm. And then it will work out, okay, what does it do? And you'll see, sure enough, that in this case, it came to the right answer of that Sally has two sisters. And it's done a quite nice job of this. It also does a similar sort of thing for the one where I spell strawberry wrong. Again, we're trying to work out, is it just using something that it's pre-learnt, or is it actually using some form of reasoning to get this? So you can see here that it's worked out that, okay, it is spelt wrong, and it actually ends up titling it that it was spelt wrong. Sure enough, it does come to the right answer in this by counting them out. Right. For me, some of the other more interesting ones are where you give it a scenario and have it think through the scenario. And it's very interesting. For example, this one, how will the global political landscape change if a new abundant clean energy source was discovered? And it goes through and it talks about different countries, which ones are reliant on oil. How would this, actually change? Because it's got a lot of thinking in there before it comes to its answer of, okay, geopolitical shifts that would happen, any sort of conflict, that kind of thing. I took the same kind of question and ran it with asking it about AGI. And I thought that was very interesting just to see its answer. And it's proposed that, okay, there would be definite changes in economic shifts, political and geopolitical dynamics and other impacts. Then the interesting thing was when in here, it talked about the whole sort of thing about being sentient in its thinking. So I asked it, okay, are you sentient? And this I thought was fascinating. The fact that it can look at this and go, okay, that's a common question, but I need to handle it carefully. I think that's interesting alone, just that it gets that. Let me start by recalling the previous conversation. So it looks at it's taking back in what was in the context window for doing that. Then it decides that it should define sentience to make sure that we're on the same page. So it does that. And then it's talking to itself about its response to me. So this is definitely like an inner dialogue kind of thing. In the end, it comes to this conclusion that, okay, no, it's not sentient, and these are the reasons why. And then it ends with a smiley face in there. So when I ask it, how close to AGI are you? Interestingly, this one, it didn't think for very long at all. And it basically just talks about that, okay, these LLMs are nowhere near AGI, which I thought is also very interesting in there. So rather than me show too many prompts, you can come in here and try it out yourself. Let's jump in and have a look at the paper and how they actually put this model together. Okay, so in this section, I'm going to dive into the paper and just talk about some of the things that were key to this whole thing coming about. Now, if you just want to learn to play with the models locally, etc., jump to the next section. I will walk through running them in Colab and show you some other ways that you can run them as well. All right, so they've released a very nice paper or technical report for this series of models here. So the key thing to understand at the start is that they actually have sort of two main models, the DeepSeek R1 and the DeepSeek R1. So the one that we're focused on really is the DeepSeek R1 because that is the better of the two. But a lot of the learning that came about to make the DeepSeek R1 came from the DeepSeek R0. So what is the DeepSeek R0? So the DeepSeek R0 is basically taking the pre-trained DeepSeek V3 model without any of the post-training stuff and just running reinforcement learning on it. So normally in a traditional large language model training at the moment, what people would do is they would do their pre-training, they would then do some kind of supervised fine-tuning, And then after that, they would do sort of alignment training with RL. And that could be RLHF, that could be RLAIF, it could even be alternatives to those like DPO, that kind of thing. So the idea here is that they don't do that supervised fine tuning step. What they do is they basically set it up so that the model will start to generate chains of thought by itself. Now, this is not totally surprising. If you think back to the original chain of thought paper, nowadays, all models are trained on chain of thought, but originally what they were trying to do is coax the train of thought out of these models with things like saying, think step by step. And you'll notice that the models over the past 6 months, you didn't need to say think step by step. Really, they've been trained to do these chains of thought. What they've done is gone back to like the old way of doing it, but to coax that chain of thought out, they've used this really interesting sort of prompt template in here. So this is a prompt that is given to the pre-trained model with no post-training at all. And it basically says a conversation between user and assistant. So basically they're sort of saying that, okay, you need to generate both sides of this here. The user asks the question and the assistant solves it. So it's kind of setting the frame of what's going on. The assistant first thinks about the reasoning process in the mind and then provides the user with the answer. The reasoning process and answer are enclosed within these think tags that we can see there. And you'll see later on when we look at these in code, you can actually see it generate these think tags and answer tags. Respectively, think, reasoning process, close think tag, answer here. And then where it's got the red prompt there, they actually put in the question that they would want and they let it go. And they start off by doing things where they could actually know what the answer is. So once they start to see the outputs of these, they can then start to work out, okay, one, is it answering in the format that we want it to? Is it using chain of thought? Is it using the tags like it's asked to, etc.? And then, of course, they start off with using questions that are things like maths and stuff like that, where there's a deterministic answer in there. So things like your GSM 8K, that kind of thing. And they can check, did this get the right answer or not? And then this can be used as the reward signal. So the reward signal is not using any kind of external reward model like people do in RLHF or anything like that. What they're doing is using this rules-based reward system to actually determine whether the response out was good or not good. Now, as they did this over time, you can see from here that what they do is they benchmark, okay, is the model getting better at some of these tasks just by itself, just from the reinforcement learning here? And you can see, sure enough, as the steps go up in here, we can see that the accuracy is going up on this task as well. You can see the DeepSeek R1 0 here is actually beating O1 Mini just with this reinforcement thing alone. Another really interesting one to look at here as well is just looking at sort of as it trains longer, it's creating longer chains of thought and longer sort of trains of thinking to do this. We can see at the start, the responses are actually very short, but okay, 8,000 steps into this, you're now getting these really long chains of thought and chains of thinking that it can then use to solve these reasoning tasks. Now, the type of reinforcement learning that they're using is this GRPO algorithm, which originally came from their paper, DeepSeek Math. And if you look back at that, you can see that, again, they were able to use that to get a huge bump over what was going on. So if you really want to investigate GRPO, you can go and have a look in this paper. The key takeaways for this is that it allows you to generate a number of things out, and it can then normalize and work out what the average best answer was, and then use that to score each of the trajectories that have come out of the model, and then use that as a reward signal to update the model. Now, unfortunately, that DeepSeek R1 0 wasn't good enough to just do that itself. And they talk about this here in the paper. They encounter things like poor readability, that language mixing, perhaps where it's not staying on track like you would want it to. So the DeepSeek R1 actually starts out with a very small amount of cold start data, and it has a multi-stage training pipeline. And the idea here is that they start off just using that very small amount, and they say it's in the thousands of examples. of cold start data to fine tune the DeepSeek V3 Base model. Then they go into the RL, just like DeepSeek R1 0. Then they go back to doing SFT, which with data that they basically created through rejection sampling on that RL checkpoint that they've made at that point. And then after that, they finally go into another RL process, more sort of akin to the traditional where people would do RL after SFT in there. Okay, so to finish up looking at the paper, I thought we'd look at the distillation stuff. So the fact that they released this whole family of models is really interesting. Now, the one sort of sad bit about this is that they do talk about that in the end, the direct distillation from the DeepSeek R1 outperformed applying the RL itself on it. So rather than use the RL for doing the small models, they actually just distill from 800,000 samples curated from the DeepSeek R1 and then use that to fine tune these smaller models. So even just taking the really long chains of thought out from the DeepSeek R1 and using them for fine tuning is able to get them to a set of these small distilled models. And remember, the smallest one here is 1.5 billion parameters that you can see these are outperforming not only GPT-4o, but Claude 3.5 Sonnet. And the bigger ones are even outperforming the O1 mini models. So overall, the paper is definitely worth a read. There's a lot of interesting information in there about how they put this together. And you've got to think that since they've basically open sourced all this sort of methods of how they've done this, a lot of people are going to be able to reproduce this going forward pretty quickly. Okay, so if you want to run the model yourself, you're probably not going to be able to run the biggest version of this. So you can see that the full size version of this is 671 billion parameters with 37 billion parameters active at any time. So you kind of want to pass on those ones, but you can come to the distill models that are in here. And these are a variety of different sizes, right from 1.5B right up to 70 billion in here. So these are both the fine tunes of the Qwen-based models and some of the Llama models, including the Llama 3.3 instruct in there. Now, if you want to run it locally on your machine with a quantized version, you can also do that. So you can see here that the 1.5 right up to the 70B is available now in Ollama. So you can just come along and install it here. You can see the different sizes, everything from sort of 1.1 gig right up to 43 gig for the 70B in there. You can also run the 1.5 and 7 quite easily in Colab. So let's have a look at that. Okay, so you can run the models in Colab with transformers. You just need a recent version of transformers. Bring that in. I'm not doing any quantization on these models. I'm just using the 1.5 one, and then later on I'll show you the 7B one. Once you basically just bring that in with the tokenizer, you can set it up quite easily to generate out. And you'll see these thinking tags, right? The open thinking tag, the closed thinking tag, and then the rest will give you the answers in code. You can also set this up as a text generation pipeline if you want for going through this, as well. One of the things that I did add to this is that when you want to print these out in Markdown, it will just automatically take the tags out unless you basically escape them. So I've just put bolding and escaping on the think tags because we want to actually be able to see those as we go through. All right, so you can see that just starting off, one of the biggest changes you're going to need to do is give it a lot more tokens for the max length. Because if I stuck to my normal sort of, 512 or something like that for these kind of questions, it will just run out often in the thinking part. So by giving it a lot of tokens, you are actually letting it to, be able to do the actual thinking part and then get to the answers part in here. I will say that for certain questions like these, the thinking is just too much, just like goes into this thinking loop and never gets the answer in a sort of a succinct amount of tokens at all. All right, you can see in here asking the strawberry question, It's able to answer it right, but it needed some help a little bit to tell it that was strawberry the fruit. Otherwise, it was sort of running out. Experiment with that yourself. The adopting personas, it's definitely not as good as other models at doing this kind of thing. It's not really being trained for that. So this doesn't really surprise me. It does, does an okay job here with the acting like a 5-year-old boy, but it's not really what this model's about. Same could be said for the creative writing tasks. It will basically come up with a long plan, but you can see that even giving it 3,000 tokens here wasn't enough to get it to get really far into the actual story. It spent most of those tokens on just doing the thinking. Where it really shines is things like GSM 8K. Not only does it get all these right, it's really doing things like the rounding and all that sort of stuff really nicely. It's outputting latex in here as well. And then the final test on this, and remember, this is only a 1.5 billion parameter model. This is tiny, this model, right? This is less than half the size of the Phi 3.5 mini, model that I did one of these last year. The React prompting is one of the things that sort of shows you that these models are not great for things like agents. In this case, it really should just be deciding on what tool to use. But you can see that what it ends up doing is that it just starts deciding like, well, why should I use a tool? I should just like give the answer. And this is really common with all the reasoning models, is that they're not really trained for tool use. And this is one of the things that they mention in the paper is that, if you need things like JSON output, if you need structured output, if you need calling tool use, etc., this model is not really for that. And this is one of the things I think that they're planning on working for the next iteration of these is to get those things in there as well for this. All right, finally, if you wanted to do the 7B, it's exactly the same. Just change this over. You will notice you tend to get longer chains of thought, it seems to me, on the bigger models as opposed to the smaller models for this, which is not really surprising in here. So you tend to get, you need to even give it more tokens for this kind of thing. Anyway, overall, the DeepSeek R1 family of models is really impressive. You should definitely have a play with it. You should definitely see where open source is at this moment in relation to the whole sort of reasoning model thing. It really does look like the proprietary companies don't have as big an advantage as people originally thought. Anyway, as always, I'd love to hear what your thoughts are in the comments, if you've got questions, etc. As always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.